If you consider voltage divider bias MOSFET, previously what we have studied, so VDD power supply we are given, and R1, R2 are voltage divider bias MOSFET resistance, and RD is output resistance, RS is the source resistance, and we can take as a coupling capacitor like CC1 and CC2, and one more capacitance we can call CC3, or it is bypass capacitor, so we can call CS. So coupling capacitor means already we are studied that it block the DC signal and allow the AC signals. So these capacitor, how affected to the low frequency we can study here. First we are converting this one into the AC equivalent. Usually when you convert to the AC equivalent, we have to know with the two theories. So first AC equivalent or small signal when you are doing, so first we are whatever DC signal is there that we are connecting to ground. And usually second portion what we are doing, coupling capacitor and bypass capacitor we are shorting. But here our aim is to low frequency response. Low frequency mainly coupling and bypass capacitor is affected. So we are not grounding or we are not shorting CC1, CC2 and CS. So we are keeping that one. Only we are doing that DC signal is grounded. So here this R1 and R2 already you people know that we can take as a this one as a one single resistance, and we can make as a RTH. That is already you studied how we can take on Thevenin circuit and this one, and instead of VI we can call this one as a VTH. So we can convert first MOSFET. This is your drain, this is your gate, and this is your source. First we can concentrate on how to convert the particular this portion. So here the very important which AC equivalent or small signal model we have to do it. Usually we can do the pi model, but the thing is RS is present, so we can go with the best method is T model. So first we can write T model for the MOSFET. So first we have anyway gate, and then we have the current source, that is nothing but ID, and then we have one resistance called 1 by GM. Okay, and this portion is G, and this portion is drain, and this portion is source. Once we are done with this MOSFET portion, now we can go with our circuit portion. So here VI, instead of VI, I will take as a VTH, because we can convert it into Thevenin and we can make it like that. So VTH, and it is connected to RSIG, then as it is connecting to CC1, so make it as it is CC1. Okay, so this is how the connection of your gate portion, and one more is connected R2 and R1. We can write directly like RTH. You people know about how to find RTH. It is nothing but R1 parallel to R2. So you can write directly. Now as we discussed, DC signal we are grounded, so VDD become ground, so we can call as a RD as connected to ground. So take from the drain here, and you can connect R0 if you want, or you can ignore the small R0. So here I am considering as a RD. So RD is connected drain and VDD is grounded. So this portion is grounded. So we can connect here one more resistance called RD and connected to ground. And the in between that RD, when you connected, we have capacitance and then V0. So make it capacitance, and it is connected to V0. Okay, so in the source portion, if you see, we have one resistance called RS, and these all connected together, and it is grounded. This portion is RS. One more portion we have nothing but capacitor called CS. So this portion is V0, and whatever this portion input VGS, and this portion we are calling input. In this case, our aim is to find low frequency. So here there is a 3 possibility of low frequency can be identified. One, low frequency we can find out in the input side what is the exact frequency is going on, and one more frequency possible in the output side. So we can consider the output side and what is the frequency for output side is going on. So we can call this one F0, this one we can call F5. One more frequency possible, because this is the source portion also there, bypass capacitor is present. So you can go with the third portion, this one. This is nothing but Fs, or middle frequency we can take. Actually these all are low frequency only, all the two we can take. We can name it like F1 and F2 and F3 for easy understanding purpose. F1 we are taking for input, F2 we are taking with respect to source, F3 we are taking in the output portion. We know that the frequency formula is 1 divided by 2 pi RC. So here the whatever resistance and capacitance is present, and that we are taking. Also we can represent with respect to W. So it is nothing but omega is nothing but 2 pi f. So if you simplify with this f and this omega, so we can get as a W is nothing but 1 by RC. So we can represent our answer in the form of 1 by RC. Case 1, we can study about what is F1 and how to find F1, and also we can represent how W1 can be find it. So for F1 we required usually F1 is equal to 1 divided by 2 pi, and here we can talk about what is the R equivalent in the input side and what is the C equivalent in the input side. We have to identify. If you talk about the input side, it is something look like here circuit is, we have anyway VTH, then we have RSIG, R signal, then we have CC1, and then we have something called RTH, or we can call RG also. Okay, it's nothing but R1 parallel to R2, and we can call RTH only. Okay, so this is what input side we have. In this we have to identify what is the R equivalent. So usually we know that R equivalent here there is a two resistance, R signal and we have RTH. So it is connected seriously, because one point is actually when you are finding R equivalent, whatever voltage source is there, that you have to ignore it and connect it to ground. Okay, so this RSIG and RTH, one point is connected, another point is connected to capacitor. So that reason we can say that it is series format. So RSIG plus RTH we have. Similar way, if you going for the C equivalent, it is nothing but we have only one capacitance, so go with that CC1. So we can easily call as a F1 is nothing but we can write 1 divided by 2 pi, and R equivalent can be written as RSIG plus RTH into we can write as a CC1. Okay, this is the how we can write as a F1. Similar way we can write as a W1 also. So W1 we are writing 1 divided by nothing but whatever the resistance value we have, RSIG and plus RTH. It is multiplied with the CC1. Okay, these are the two important formula for, one is for W1 and one is for F1. If you understand F1, you can convert into the W1 and you can represent it like that. So in this the main aim is to our find is what is the R equivalent and what is the C equivalent. Similar way we can go for the case 2, we can find out what is F2. When you go for the F2 is nothing but we are concentrating with the this portion here, whatever this portion is there, this we are considering for F2. So we can take the circuit diagram for that. So it is something like 1 by GM, then it has RS, and we have capacitance like CS, and then we have connected to ground here. So here we have input actually VI all this portion. As already I told, if you are finding R equivalent or C equivalent, make it this one shorted and connect it to. So whatever VI portion is there, just ignore it and connect it to ground. So we know the formula for F2 similar way, that is nothing but 1 divided by 2 pi R equivalent and C equivalent. Here our case, what is R equivalent look like? So when you go with R equivalent, it is nothing but we have one resistance RS and 1 by GM also resistance, because GM is a transconductance. We are representing conductance is 1 by resistance, so it is 1 by GM, and the one point is connected together Because of Vi we are ignored and connected to 0, it's a short circuit. So this point and this point both are same, so it look like a parallel. So when you are taking like this, so 1 by Gm parallel to the Rs. This is the R equivalent circuit in the F2 case. When you going for the C equivalent of the same circuit, so here only one capacitance exists, Cs, so we can go for that. So the final answer of F2 we can write something like that, 1 divided by 2 pi R equivalent nothing but we can write as a 1 by Gm parallel to Rs. Here one more stuff you can remember, that the Rs is actually very high and Gm are very small. So that reason we can ignore the Rs and sometime we can write R equivalent almost equal to 1 by Gm also holds good. Because already I told in any parallel, any one term is very high, another term is very low. So usually we will go with the very low answer. When you are doing after the parallel also you will get low answer, low value answer. So that reason we are going with this answer holds good. Or you can write both parallel to Rs also, not at all wrong. So next answer we have Cs. So this is what F2 can be written. Similar way we can write W2 or omega 2 for this is nothing but 1 by Rc is nothing but 1 divided by 1 by Gm parallel to Rs and multiply with the Cs, and it almost equal to, we can write like that, 1 divided by 1 by Gm and multiply with the Cs. Now we can discuss about case 3, that is nothing but F3. So when you're going for the F3 answer, here F3 we are only concentrating with the this output portion. So similar operation, we have one resistance known as Rd and we have one capacitance we can call Cc2, and then we are getting as a V0 here. So this is grounded. Here only one resistance and one capacitor exist, so no need of the any equivalent. So we can directly go with the F3. So F3 is nothing but we can write 1 divided by 2 pi. Instead of R we can write R equivalent is nothing but Rd and C equivalent is nothing but Cc2. Similar way we can write omega 3 also is nothing but 1 divided by Rd into Cc2. So these are the different answer of the each frequencies. Now the question arises, which one is the low frequency? We have discussed about low frequency is actually because of these three capacitance, which one usually we can take as a particular low frequency. So for low frequency there is a one more term we can have, FL is equal to maximum of these three frequency, F1, F2, F3. So this is the what the exact answer for the your FL. So how to find FL means we have to find F1, F2, F3 together. Then which one is the maximum of this F1, F2, F3? That one we are calling as a low frequency. We can discuss about one example of the lower cutoff frequency, how to find in MOSFET. So find lower cutoff frequency for MOSFET amplifier. The given term is K is equal to 0.4 milliamp by V square and Vt is 1 volt and circuit is given. Here VDD is around 20 volt. Whatever VDD is, that doesn't matter for the our circuit. So RSI is given as a 10 kilo ohm, and then other this resistance whatever we can call as a Rd, and this capacitance we can call as a C1, and this capacitance we call as a C2, and similar way C3 or CS in this side. So all the this is Rs. This is what we previously discussed, RTH or RG, whatever you can take. And one extra resistance what we are discussing in the previous, here we are not used RL, but here they are given as a one load resistance 2.2K. So only in the F3 formula there is a small changes, all other as usual we are discussing like that. So here we converted this R1 R2 is together and made as a RTH. Similar way here directly they are given, so ignoring with the voltage divider bias, so take only this portion. So in the solution, first we can find out what is F1 and then so on like that we can continue with the other stuff. Case 1. we'll go with the input to find F1. So we know the formula from the previous relations. F1 is nothing but these input portions whatever we have. So from this we discussed that F1 is equal to 1 divided by 2 pi, and we have two resistance RSI and RTH. These are series connection, so it is nothing but RSI plus RTH into we have C1 or CC1. Okay, this is the formula for F1. If you take like that, the 1 2 into pi, we know that pi value, you can take that, and RSI is given 10k, so take 10k, plus RTH is given as a 1 mega, so take 1 mega, and multiply with the C1, that is nothing but 0.01 microfarad. If you simplify this one, you will get one frequency F1. Just pause the video and calculate this one. You will get F1 as a 15.8 Hertz. Similar way, we can go for the case 2. So case 2 aim is we are making in a output portion. So what happens in the output circuit? In case 2, we can find out source circuit to find F2. So here we discussed what is F2 and how to get it. So from this you remember that F2 we got equation something like that. So you can copy that same equation. So F2 is nothing but 1 divided by 2 pi, and we can call as a 1 by GM parallel to the RS and multiply with the CS. So here we have 1 divided by 2 pi value we know, RS value we know, CS value we know. Our aim is here what is 1 by GM. To find GM we require usually something like ID and VGS usually required. So how to find this ID and VGS? We know the formula for GM is nothing but ID by VGS. So here in our case ID and VGS both are unknown. So first we can find out what is ID. So when you are finding ID, we have to know that the thumb rule already I told how it work, and here when you are going with the VDD 20 volt, and thumb rule means the 3 division it will take. So 20 divided by 3 you will get nearly 6.6 something, okay, or you can take 7 also, okay. So that voltage into the VD. So we can make something like that. Whatever from the thumb rule, we can say that the voltage across the RD is nothing but VDD by 3 volt. Okay. So that voltage divided by whatever the RD resistance we have 4.7k. If you simplify this one, you will get ID value. This ID value you have to apply for the one more formula of ID equation. ID is equal to K into VGS minus VT whole square. Here K value is given 0.4 and VT value is given 1. So ID you will get from this portion, and the thing you have to find is VGS from this. So once you identified ID and VGS, you will get the GM value for that one. Try simplification from yourself. So you will get the values. So VDD is nothing but the value is 20. So 20 divided by 3 divided by 4.7k. This is your ID value. So whatever ID value you will get, apply to this portion and simplify this K and VT value, you will get VGS. So that apply to the your GM, and you will get after the all the solution GM is 2 milli. So I am taking this directly to the GM value. So we got GM is 2 milli, and from that we can apply the formula F2 is equal to, we will get like 1 divided by 2 pi, apply the pi value, and then 1 by GM is nothing but 1 divided by 2m, and it is parallel with the RS. RS value we got as a 1k, so we can take as a 1k, and then it is multiplied with the CS. CS is nothing but C3 here, that is nothing but 2 microfarad. So if you multiply all those stuff values, you will get the F2 value. So F2 value usually you will get as a 238.73 Hertz. So try to solve these values and find out the F2 value. Similar way, we can find out case 3 F3 value. So F3 value, we can use the output circuit to find that. So we know the formula for the F3. So F3 here, there is a small change what we have discussed previous. 1 divided by 2 pi is same. But here resistance, there is a 2 resistance. So we can take as a RD parallel to RL, and then it is multiplying with the your C2. In previous theory part, we are only taken RD into C2. Here we have to take both RD and parallel to RL because RL present here. So if you simplify this one, 1 divided by 2 pi as it is, and RD value we know that 4.7K, and we got GM is 2 milli. So we can find out our F2 from this portion. F2 is equal to 1 divided by 2 pi. 1 divided by GM is nothing but 2 milli apply, and parallel to RS. RS is given as a 1 kilo, and these all are multiplied with the your C3 is nothing but 2 microfarad or CS. Okay. So if you simplify this one, you are getting as a 238.73 Hertz. Similar way, case 3, we can find out what is the particular F3 at output circuit. So here the small changes in the previous circuit, if you take like that, we know that when you are converting into the small signal, VDD become 0, or VDD we are connecting to the ground. So this is your drain portion. So drain, the first connected to the RD, so we can take RD, and then the VDD portion we are connecting ground, so is connecting ground. After the RD, it is connecting to the 0.5 microfarad, so go for 0.5 microfarad, and then we have RL, so it is connected something like RL, and it is connected to ground here. Now this portion is nothing but V0. Okay, so in this case, if you're taking, we know that F3 is nothing but 1 divided by 2 pi R equivalent and C equivalent. In this output circuit, C equivalent we can take nothing but C2 because it's only one capacitance, so we can easily do that. Now very important, what is R equivalent? So here in this case, the one end is connected to ground, another end is connected not together, it is connected to one end of the capacitor, so it look like a series. So RD plus RL we can take. So our F3 formula become 1 divided by 2 pi. Instead of R equivalent, we can apply RD plus RL. So these are multiplied with the our C2. So if you apply the values of that, so 1 divided by 2 pi, RD is nothing but 4.7K, adding with the RL nothing but 2.2K, and multiplying these two things with the C2, that is nothing but 0.5 microfarad. From all these three, we can get F3 is 46.13 Hertz. So from these relations, we got three frequencies. So first one we got as a F1 is 15.8, and F2 is 238, and F3 is 46.13. As we discussed previous, the FL can be find out low frequency. It is always the maximum of the F1, F2, F3. So if you take in all these things, maximum is your F2 value. So FL is nothing but, F2 is nothing but, in this case it is 238.73 Hertz. So the summary is that if you give voltage divider bias of this circuit, so if you want to amplifier, you have to give more than 238.73 Hertz, then only it acts as a amplifier. If you give lesser frequency of 238, then it doesn't act as a amplifier. That is the conclusion from this calculation.